Well, I've got exactly 3 minutes to start this Manor Kestrel, which belongs to one of our club members, the amateur radio club, not CB club. He had one as a teenager and he spotted this at a radio rally. It's pretty immaculate, and he said, no lousy pots, noisy pots. Can we supply one of our power leads? And the answer is yes, we can supply one of our power leads. And there is one of Mr. Chippie's power leads, which we will use it with. So that's a good start. So I better open it straight up. I like to get this done today, and my working day finishes in 5 minutes. So that isn't going to happen. There, put the soldering iron on. It's pretty immaculate. Right. Right, power it up. And quite rightly he says the thingy doesn't work. Right, we'll start by checking it in PA. Testing 1 2, testing 1 2. Did I say it's got the... Ooh, that's a dirty volume control. Whoa. Are they the type you can clean or the type you can't clean? Theoretically the type you can't clean, but you can usually get spray between the rivets. I could get, if all else fails, we'll get Mr. Chippie to strip it down. Testing 1 2, 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 testing 1 2. Well, it seems to have got in there, doesn't it? So, dirty volume control, no meter lamp, PA working, mic working. Let's go over to, we'll put picture in picture on, can find the right button, and we're in the 3 watt scale, and all we need to do is plug into the test gear and take it out to PA. Right, it's just doing more than 3 watts, 3.1. You don't usually get these above 3.5. Really good audio, so it more than makes up for it. That's interesting. It's usually lower on the higher on the lower frequencies. Right. Why is the relay cover missing? It's not inside. What's that about? With these relays, I was able to buy them as a Canon, as in photography, spare part for a studio photo flash for about 27 quid each as a Canon spare part. It just goes to show how much profit they put on at Canon on spare parts. Because you're not telling me that that relay is worth more than £3.99. But anyway, I did buy some, and I might still have got one in stock if that's faulty. But why the lid's off it, goodness only knows. You never know, we might have a scrap chassis with a relay lid. But of course, most of the relays have been pinched off scrap chassis, and yet they're still producing new sets with relays in them. I thought it was old hat in 1981. Right, let's see what the receive's doing. So I'll tell you what, we'll see what the transmit frequency is for a start. 2779052. 2779052. So I think we'll bring that up right now so that we're not faffing around with the signal generator. I dropped the trimming tool on the floor. So just do that. Well, I'll tell you what, it goes. When they're getting that low, you start to think 26, 27, 79126. Dial that into the signal generator. I thought I'd put the frequency counter up, but I'll just show you that again. 27, 79126. Just put the signal generator on, as I said. That's near enough. And plug into the other socket. That sounds awful. Do I need an earth? Yep. Right. Let's see what the cyanide meter has to say. Make sure RF gain's fully up. .63. I think they're capable of better than that. It sounds a bit detectorish. 0.58. 0.78. Squelch to full. See where that comes in. Comes in at 1000 microvolts, and at minimum sensitivity 1.1 microvolt. Usually they work better than that. The S meter, see where S9 is. We can, I mean, you can't see that, I can't see that. To be honest, that looks to be 100 microvolts. I think we'll put a bulb in that before starting to fiddle. I'm going to have to leave it at that. I'm just concerned about no relay lid. Right, I'll carry on with this as far. I'll take the picture off. Get this meter done. Mega run out of time. Take that bracket off. try and get this out. So what I'll do, I'll chop the wires off. Get this out of the holder, then we put a new lamp in the holder. Especially if we have some. Making sure they're 12 volt and not 6. I think we'll glue that in the holder. I'll just use Bostik today. I think we'll call it an evening. I think we're coming up to 9 o'clock. I'll tell you what would be sensible, and that's to do the deviation with it in bits. Then I won't need to put that test set on tomorrow. So deviation is that one there. Right, let's get the mic plugged in. Factory original. Channel 20. Wow, it's a bit low at 1.8. Wow, the bleep is. Yeah. Right, we'll leave it at that. Okay, so it's the next day, and I've done the meter lamp, so let's see whether it lights up and whether the meter goes the right way around. Yes, yes to both. Right, better plug things back in. So plug the mic in, we'll do the transmitter. So I've actually done the hardest part of the work. I mean, that took probably the best part of 40 minutes. The bulb I took out, if I've got it on here, probably not. I mean, obviously the ones I'm going to put in are slightly different, and so I kind of glue it into the, it's not a holder, because it's a wired-in bulb, but I kind of glue it into the receptacle, and I had the opportunity to let the glue set overnight. We'd have probably used hot glue, so it was quicker setting, but I used the organ builder's favourite Bostik adhesive for that. So we've got a previously written out chart. I've just seen that relay. I've forgotten about that overnight. Don't like seeing that. Okay, so we'll put the test set. Let's go into picture in picture, and we'll put the test set back into the right mode. We're on channel 20, and we're at 3.1 watts. So we'll just go. I'm going to start here. That's very critical. I don't think this set's being touched, you know. It's not warm enough. Still not warm enough. I'll be getting the hairdryer out that I don't have. Yep, it's moving. Of course, it was in exactly the right place. Check the placement of that. And that's come unsoldered without me doing much to it, so I'm kind of glad it happened here and not with the customer. That really needs to be in that, not just on the edge. We're just using traditional lead tin solder, not the RoHS compliant modern one. I'm going to let that cool down because now it's warmed up. It's 3.1 watts, which is what we started off with, but I think we're nearer 3.4. So we'll let that cool down. I've done the deviation, as you know. I'll tell you what though, we'll do the RF meter. We set it at 4 regardless, and it's the one at the back. It's exactly where it should be. It's in the centre of the red zone. So deviation was there, RF meter's there, it's got low power. Is it on the back? It's on the back. So let's see where low power is. I didn't write that down initially. So So let's see where it is now, and it is at 290 milliwatts. And if I can get the tool back out, it's 400 milliwatts. Back to full power, we have current consumption 1.14 amps. That was 2, it's now 2.2 to 2.5. RF meter was correct before and it's correct after. We can actually read the S meter now, and we've got 100 microvolts on, and it's a little tiny bit generous. It's at 54 microvolts, which is actually where you'd have it for a ham radio. But for a CB radio in the UK, it's 100 microvolts. Right, so whilst that all cools down, we'll do the receiver. I'm sure you all realise CB radio is only something like a 3% transmit what's it, duty cycle. I'll pop that on any coil which is connected to ground. And we're not going to touch again. You know what? We're going to end up putting this on the power supply negative, aren't we? Right. So first thing we want to do is do the detector. Ratio detector, it's not normal for a CB. It's kind of like about a 1977 design on a 1981 radio. It was quite an old-fashioned design when these were made, but that doesn't mean it's a crap design, even though everybody hates them except me. So I'm going to check that. This is 10.24 injection to the receiver. So it's how much 10.24 from the crystal oscillator used for the synthesizer actually finds its way into the receiver as a reference for its intermediate frequency. So here's your first stumbling point. I'll use the synod meter. Well, so I don't think this has been fiddled with, so we might be alright. See how that was worse instantly? And it was absolutely spot on as it was. So I think we'll do the front end first. We've gained an improvement there. And we've gained an improvement there. They don't want you to touch that. I've got more instrumentation than they probably had at the factory. That looks like it was miles out. Now I just want to, I've done that with the synod meter, I've done it with the oscilloscope. I just want to see where the S meter is. And so I'm going to pop that onto a higher sensitivity so I can see if it moves. S meter is the preset, which of course you can't get too easily. So I've popped up the sensitivity so I can actually see the meter move. I just want to make sure that these IF ones not only are the best cyanide and the best oscilloscope, but also are at the right side of the meter, because you can end up tuning the wrong side of the signal and then you'll see the meter go down. So that's correct. That was correct. That was correct. Now we're going to move the one you're not supposed to move, because we can. They wouldn't have had a cyanide meter at the factory. And there we go. So we're just going to touch up. If you don't have a cyanide meter, don't touch that. I'm just going to drop the signal a bit. We'll just go through these two front end ones once again. And then finally we'll just go back to the detector to 100 microvolts. There we go. Absolutely. Right, now for the moment of truth. Is it better or is it worse? You fixed my radio worse. Right, we've got 0.62 to beat. Oh, it's looking better. Let's go back to the cyanide meter so you can see where my reference points are. So I'm just going to touch the chassis and make sure it doesn't make any difference. No. .41. .37. .6. Right, where's our squelch? So there's full squelch. 3, 10, 30, 100, which is where I want it to come in. And now I've done the retune, it never comes in at all. So you see I fixed it worse. Right, so what we'll now do is adjust the squelch, which, if I can see it, is somewhere around there. I'm not a lover of vertical presets. So maximum sensitivity, which is where I've now got it. Oh, on the preset. Get the tool back out. Isn't quite where I want it, but it's not far off. It's 250 microvolts. And hopefully this will bring down this, which, to be honest, would be chattering round scratchy corner. One of those. So let's just see whether we have fixed that. Well, I switched that signal generator to standby. No, I hadn't. I've got the dentist later on this morning, and obviously I'm in England, in the United Kingdom, and we do have the National Health Service, the NHS, and I do have an NHS dentist, which is quite difficult to get, and they have charge bands, so you go for a checkup and it's about 26 quid. So this is part of the NHS where, regardless of age, you do have to pay something unless you don't have a job, and you've jumped through all their hoops. So even if as a pensioner you will pay unless you fit some poverty criteria. So the thing about going for a dental checkup isn't so much the pain, is you don't know whether they're going to say, oh, that's absolutely fine, Mr. 21, that'll be £26 for a checkup, whether they're going to say, oh, you need a filling, and in charge band 1 that'll be, you know, £56 or whatever, or whether they say, well, I think we're going to have to spend £400 on you, you know. So, so that's always it's the financial worry, but I'm sure it's less than a lot of countries end up paying. So I do see the dentist every 6 months. Where are we? Oh yes, minimum sensitivity. So set squelch on the radio to minimum. Signal generator back on, parked at 0.3 of a microvolt. I'll put that up on the inset picture, if you can see it for the paperwork. So we're at 0.3, so we're going to switch the signal generator back from standby to on. It nearly came in. You can see it chattering about 0.6. It's 0.7. That won't be a problem around scratchy corner, and these sets do have good squelch. So 100 microvolts on the S meter. Of course, I've bumped that up for the test I was doing. So we need to just reset that. It's the preset there. And that's S9. So that's that done. Switches. They tested out okay. Potentiometers. It's a noise on the tone control. I'll just see if I can spray between the rivets like I did with the volume control. Sometimes you can. Otherwise it's Mr. Chippie to the dismantling department. That's disconnected part of the speaker, isn't it? That's the service hole on the floor. That's now lost its spout, which will be difficult to find. I'll put that on a coil again. Drop the signal generator, make sure the squelch works. Yeah. Make sure RF gain works. Let's seems reasonably smooth. Check it works in channel 9. It does. Right, well, I reckons... Oh, of course I've not done the transmitter, have I? Just need to see what power output we're actually getting now. It's not been transmitting solidly for 6 minutes. It's 3.4. And channel 1. It's 3.3. Channel 40. Is 3.3, so it's well balanced. So just for the record, if I take the power supply up to 14.4 volts, which is like if it was in my car and with the car on, what's the transmit power now? It's actually 3.5. I'll drop that back down. There we go. This really doesn't affect range. I've said a million times, if you had a record player which was 3.4 watts output and then you put a different record player on which was 4 watts output, there's no volume difference. It works on decibels, and really, unless you're getting under 2.7, you're not going to notice any range difference. It's all been well thought out, this, and you know, we've done this, we've demonstrated on 28 megs amateur radio, you know, what 40 watts will do, and what 4 watts or 5 watts will do, what half a watt will do. So we've shown similar things, and to double the range you've got to square the power, haven't you? So anyway, right, so I think we're done. I will just show you the bottom of this radio, and you see that is factory washed in a chemical cleaner. I don't have to go over that with isopropyl alcohol, and so many sets I do. So, you know, there you go. That's where I've soldered the meter lamp to the series resistor. So, no dry joints. Sometimes it's not the manufacturer's fault on dry joints. The heat spots are going to create dry joints. But this hasn't had high hours, and so I can't see there's any heat spots which have done anything to it. So I will try and put this customer's immaculate set back together. It will open and close like a bookcase. I'll put the knobs back on and I'll come back to you. Right, so I may as well do the serial number before we plug in. 032804. What's that? Serial number 4? Right, we're done. So the relay has no cover. So I'm sure for £27 something we'll put a new relay in. But it hasn't played up. I don't know. Here's a strange thing. Why would someone take the cover off the relay when this is a low hour set? Did they think the relay contacts were dirty and they've taken the cover off? I don't know. We've got a scrap chassis here, but of course the relay is missing. This is a Planet 2000 version, and it's got knobs. So, you know, great. It's also got a synthesizer chip. We've only got 2 scrap chassis of these because I fix them all, don't I? And we've not had any which have been flooded or anything, so they've all been resurrectable. These were £89.99 new. And that knob should really be saying Manor Kestrel as near to the... Yeah, it doesn't though, does it? It doesn't line up ever. Right, let's see if there's any good buddies out there at 8:30 in the morning. One Anna Roger. So we've got a Thunderpole 3000 new set for optimization, which is the next job. This is from a trucking company in Leicestershire. It's the same one, same firm who owns the one which I'm waiting for parts for, but this is a new set for optimization. We're going to do that next. We've got a... I understand it's a sealed bag York 863 to do. What else have we got? We have got another new Thunderpole 3000 which has been ordered for a customer, which will probably be next Wednesday or Thursday. I know you're going to get fed up seeing them, but they can perform differently, can't they? And I originally did plan, when we started this channel, to just do one set. So one Manor Kestrel, one Maxcom 4E, and one Harvard 420M. But people enjoy seeing the different ones, and when you're doing repairs, it's that detective work, isn't it, as well? So, is that paint? I think someone's had the... Anyway, I'll let him deal with that. So that's worked out really nicely, and I'm going to try and do another set today, but there's no promises. I want to also show you a little video which was unboxing a 1956 record player I bought on eBay. So that won't be interest 99% of you, but there you have it. So thanks for watching the Manor Kestrel from 1981, and it works really well.